There are several concepts in aviation that come in sets or groups, such as the 4 forces of flight, the 4 fundamentals of flight, the 3 movements of an airplane, and the 3 axes of control, all of which we've already discussed. One that we haven't yet talked about are the 3 airplane design characteristics. These 3, which are stability, controllability, and maneuverability, determine how the airplane flies, how safe it is, and how suitable it is for its mission. Stability is the aircraft's ability to correct for conditions that disturb its equilibrium, you could say, and return to normal. In other words, stability determines how much the airplane takes care of itself. For example, let's say the plane encounters an area of turbulence or a crazy panicked control input from an anxious beginner pilot. The aircraft's stability is going to dictate how well the aircraft can return to straight and level flight after experiencing these disturbances. Aircraft with high stability are going to be smoother and more forgiving. This is common in training aircraft. Aircraft with low stability are going to be more responsive but require more attention and caution from the pilot. Alright, next we have maneuverability. To use a more circular definition, maneuverability describes the airplane's ability to be maneuvered by the pilot and withstand the stress imposed by those maneuvers. Basically, it's how quickly and easily the airplane can change direction and attitude, or orientation, while in flight. High maneuverability allows for tighter turns, rapid climbs, and quick attitude changes. When you think of aircraft with high maneuverability, you'd probably think of fighter jets or aerobatic aircraft. The more maneuverable an aircraft is, the quicker and more agile the movements it is capable of. Aircraft with lower maneuverability are going to have steadier, more efficient flight like an airliner. Finally, we have controllability. Controllability is the aircraft's ability to respond to the pilot's control inputs, especially with flight path and attitude. This is all about whether the pilot can command or control the airplane effectively. Good controllability ensures the aircraft responds properly to control inputs. Without sufficient controllability, even a stable airplane would be deemed unsafe. For example, if you are in a hazardous situation and need to pitch the plane upward, you wouldn't want it shooting down instead when you pull back on the yoke. Controllability is pretty much how obedient and predictable the aircraft is, and is most critical during takeoff, landing, and any abnormal situations. In a nutshell, highly maneuverable planes are generally less stable, and inversely, more stable planes are usually not as maneuverable. An inherently stable airplane is going to be easier to control. Now, before we wrap up, there's a more specific concept under stability that is good for you to be familiar with, and that is what is called longitudinal stability. Longitudinal stability is all about how an airplane behaves in pitch when something disturbs it, like turbulence or a gust of wind. An aircraft is longitudinally stable if, when its nose is bumped up or down, it naturally tends to return to its original angle of attack and airspeed without the pilot having to fix it. That was kind of a mouthful, so I'll rephrase that. Basically, if the nose is bumped up or down by some sort of force, again, whether it's wind or turbulence, if the plane can naturally restore the pitch that it was at, that is how you can tell if the aircraft is longitudinally stable. Again, if the plane does it on its own. The cause of this comes from what's known as the center of gravity and the center of lift. The center of lift is the central upward force on the plane, while the center of gravity is the central downward force and sort of the aircraft's balancing point. For stability, the center of gravity must be in front of the center of lift. If the center of gravity is too far aft or back, the airplane gets less stable and control becomes twitchy. This is the main reason to be careful how you load the plane. Balance is a big deal and crucial for proper stability. Now, something that a lot of textbooks and instructors kind of just tend to quietly gloss over is the answer to a question you might be asking yourself. Why is it called longitudinal stability if it's measured by pitch, which is centered around the lateral axis? Funny you should ask. For some reason, we name stability after the direction of motion being affected, not the axis the airplane rotates about. Let me say that again. We name stability after the direction of motion being affected, not the axis the airplane rotates about. So, even though it's measured by the lateral axis, longitudinal stability is about motion along the airplane's longitudinal direction, like the pitching motion. This is why it's called what it is. Now, that's not necessarily mandatory information for you to know, but it can help keep you from getting tripped up in the future. Okay, In the next lesson, we're going to start on instrumentation, beginning with the instrument panel and covering the basics of what each instrument does. For the most part, that's pretty simple. The more complicated portion comes when we talk about the internal mechanics of each one. Don't be worried about that though. I'll go at a nice, steady pace, put together some short quizzes along the way, and we'll get through it no problem. Also, remember, if you ever have any questions, feel free to reach out to me through my email, which can be found in the channel description, or you can just leave a comment. Thank you guys. I'll see you in the next one.